fast. So let's start talking about filtering our data. We talked about this a little bit in the context of what it meant to select our factors in our columns and how that was sort of targeting in on elements. But filtering our data is a more complicated subject. When it comes down to filtering our data, it isn't necessarily just because we want to hone in on just a little piece of something, but oftentimes we do it just because the data that we would like to have is not often the data that we have received in its raw format, right? When we are getting our information, it could be recorded in basically whatever arbitrary way whoever was collecting that data decided that they were going to store it. But as we talked about before, we have to have our data in a particular format, that tidy format, right? The tidy format isn't necessarily the Platonic ideal. It's not necessarily correct in all possible ways, but it is a standard format that we are using. And it's not necessarily the way that our data is going to be presented to us. If we look at the sort of data that we have, in the real world, a lot of times it's going to be just messed up. And a lot of times that's because whoever's collecting the data is collecting incomplete or partial data. We have an example here that is from a website called askamanager.org. And basically, it's a whole bunch of live data responses from folks in various industries in getting some context into their salary, where they work, and et cetera. And importantly, when they are doing all of this stuff, when they're surveying people, sometimes people leave fields blank. Maybe they don't think it's relevant. Maybe they decide that they don't want to because it just doesn't feel like something they want to share. And so if I look at this form of the data, this is a CSV that's on, or a spreadsheet on Google Docs here, we can see that a lot of the fields are pretty consistent. Stuff like what industry do you work in seems to be pretty well filled out. Other things are absolutely not. Stuff like if your job title needs additional context, please clarify here. For obvious reasons, a lot of people don't think any extra clarification is needed. They just leave it blank. Other stuff is a bit of a problem because whether or not they put it in, maybe you do want something there and maybe it would be appropriate, but there was a little bit of vagueness about whether or not it should be there. We can see that there's this category or this column, how much additional compensation do you get? A lot of people put $0 in there. They don't receive any additional monetary compensation. Other people said, I don't receive any additional monetary compensation. This question doesn't apply to me, and they left it blank. That's a bit of a problem for us because if we try and run some calculations on one of these columns where there are undefined values, it's going to get a little bit nasty. If we try and take the sum of all of these values that include 0 and 4,000, 7,000, 10,000, and then also the total absence of any mathematical value, what do we expect is going to happen?
It's not going to run, or it's going to throw something up that's not.
It's going to make the data lower because you've got all those zeros in it.
At best, we can expect that maybe whatever we end up doing, it will make some assumptions about what it is, and we hope to God that whatever assumptions were made by the system are correct, which is not necessarily always going to be the case when you have something that's got blank data. Realistically, because the system probably can't predict what's going to be in something, there's a pretty good chance that we're going to start encountering some crashes if we try and run on data that hasn't been cleaned up first. Because there's a good reason that we're expecting everything in tidy format. If it's not, we don't know what to do with it. You could put anything in this. We don't know what these columns mean. The semantic meaning of it is something that only you, the programmer, can know. So when it comes down to our data, if we have this dirty data that is just missing information, we're going to need to do some cleanup on it. And even if we don't need to necessarily clean our data, we do need to be mindful that we might only want certain parts of it. So if we go down, and I'm going to use the website for this part. In this portion here, we have the same data frame that I was just looking, or sorry, the same data that I was just looking at in the spreadsheet. This loads it into a data frame and it outputs it into text. This is going to be basically the same thing that we were just looking at, but in the console now. Aside from the problems that we previously encountered, there are a number of different other things that we might find. that we might need to consider cleaning up as well. Certain things like when people put in what country they're from, some people put stuff like United States, other people put in things like US. If we try and pop that into a chart, does the chart know that the United States and the US are the same?
No.
No, and neither did any of our statistical tests or anything we're doing. So there's a lot of need to clean up our data or to filter it for certain kinds of things. Because reasonably, we might want all the information just from the people from the United States. We might want to filter just to get those people. But before we can even do that, we need to make sure that all the people from the United States put it in the same way, or at least that it is the same way after we've cleaned it up. So to start with, let's start by talking about filtering on rows of data. What are some examples where I might want to filter on the rows of a data frame? I want to select some rows, but not others. What are some examples of cases where I might want to select some rows, but not others?
Well, I mean, I do that kind of stuff where, like, if I'm looking at student data and I want to just look at seniors versus freshmen, you know what I mean?
Totally.
You know, so I had to sort it and then have that just find all those people that it's done by row because the data's on that row. Yeah. So something like that. We do that a lot with Excel. I mean, we do a lot of filtering by rows. And I mean, we filter by columns, but we're looking at row data. So,
yeah, absolutely. You might end up filtering on the rows because you're only trying to look at specific things. But if your data set includes a whole bunch of it and you only want to look at a subset of the data entries, that's when filtering rows becomes really handy. So the example that's presented in the tutorial is something that's a little more arbitrary than the one that you're talking about. They have a small data frame to have an example where there are two columns, X and Y, and the values for these rows go 1, 5, 2, 6, 3, 7, 4, 8. That's the entirety of that example data frame. In this example, we suggest maybe we only want to look at Y column or rows with a Y column value greater than 6. That's pretty arbitrary, but it's reflective of, like Derek was saying, some real world examples where you might have something where maybe these aren't numbers from 5 to 8. Maybe these are the school year of a student. Maybe this is any number of other real world qualifiers that we care about only looking at parts of it and not others. In terms of how we actually do that, we can use the filter action in order to start getting some subsets out of our data. This is going to be a little bit different than some of the other actions we've done, but I think the easiest way to see it is just going to be to actually try it out. For this one, we're going to use a different CSV file. This is the random CSV file. You can download it if you want to use it in Quorum Studio, but because I'm doing it on the website, it's already there, along with the code that runs it. And in this particular example, the values in it are basically gibberish. The first column is ID. It goes 1, 2, 3, 4, 5, 6. Basically just a count of which row everything is in. And then it has 3 columns, A, B, and C. And the numbers inside of it are just random values that seem to go from somewhere between 0 to 350-ish. There's not any really rhyme or reason or structure to the code. But what's important to know is just that we have 6 rows of data, these 4 different columns, and we want to only look at certain values. For this example, let's suppose that we just don't care about anything that has a value in the C column that is greater than, that is greater than or equal to 35. The C column right now, we can see that the rows have 9, 5, 18, 48, 90, and 25. If we only wanted the values that are less than 35, what we really want to do is we want to get rid of rows 4 and 5. I can use my eyeballs and I can use a cursory examination of this data set to see that I don't want rows 4 or 5. So should I just go say remove row 4, remove row 5? Is that a reasonable way I could approach this?
Unless in B and A, there's something you want in that row.
So that is a potential concern that we might have. It's like, well, what about if there's other values in these other columns that might be relevant? But for right now, let's assume the only thing I care about is making sure that I look at values where the C value is less than 35. So this might be like, to use Derek's example again, the filtering based on what grade you're in or what school year you're in. I don't care about anyone that is beyond the certain threshold because that value is just not important to whatever I'm looking at right this second. So I want to get rid of those. So is it reasonable in that case where I know with certainty I don't care about these 2 rows because they're greater than 35? Would it be reasonable to say, please remove rows 4 and 5? To put it another way, how do I know that I want to remove rows 4 and 5?
Because the values are greater than.
Right. How do I know that those particular rows are greater than? Because I just inspected the data set and I made that decision intellectually, like looking at it right this second. Suppose that we just had our wine data. It's 60 rows. That's tiny in the grand scheme of things. Do I want to inspect 60 rows individually to figure out which rows I want to get rid of?
No.
No, that's the problem with trying to remove individual rows, is it does not scale at all to data set that is of any decent amount of size at all. Even just looking at this one where it's 6 rows, no, it was slower for me to go and manually evaluate with my senses and with manual sort of interpretation of the data what I wanted to get rid of, rather than just putting it into the computer and just letting it handle for me. And this is only 6 rows. So what we're going to want to do is we're going to want to use the tools the data frame has for us to apply a sort of rule or order, a structure upon the data frame that we don't have to manually do it ourselves. So I'm going to go ahead, I'm going to scroll down and not running it yet. This is just looking at the code. I have here some code that we're going to use a data frame. It also has a use statement for something called a remove undefined rows transform. Don't worry about that for right now. It doesn't even get used in this program. It's extraneous. What is actually important is that we have 2 data frames. We have a data frame called frame, and we have a data frame called copy. Before we talk at all about how the filtering is going to work, why would we want to make a frame and then a copy?
In case you want to put back what you take away.
Basically, yeah. It's exactly what you were just commenting on. We commented on why might I not want to remove rows 4 and 5. It's like, well, you might not want to remove that if there's other information in there that you care about. When we filter, we're going to get rid of some of the information that's in there. If we make a copy first, we'll make sure that we still have the original data if we want to go back and do anything else on it. In order to actually make that copy, in the next couple of lines here, we do our normal load call. So we have frame : load, and then it goes to some path and gets some value from somewhere. And then on line 14, we say copy equals frame : copy. So we haven't done any filtering yet. All we've done is we have made one data frame and we've copied the contents of that frame into a second frame. So we have 2 copies of the data now. So after that, we have this line of code here on line 17 in this faux text box. Frame : filter, left paren, quotation mark, C less than 35, quotation mark, right paren. This is a little bit of a weird call. What does it do, first off? What do people think it does in the context of everything we've been talking about?
Pull data that's less than 35 only.
Yep. So we're gonna cull it. So if C is less than 35, it's going to filter that data. And so when we're filtering, is the data still there, or is the data that's below 35 going to be kept, or is it going to be removed?
Kept. 50-50 shot.
Let's find out. That's right, 50-50. Well, unless there's a mysterious third option where I've like got a compiler error or something, right? But if we go and we look at our data, we can see that in the modified version of this, the information that was less than, with the C value of less than 35 is still there. So we've got rows with 9, 5, 18, 25. There's a couple of extra rows in this particular version that we're using. But the important thing is, yes, when we use the filter call, we kept the stuff that satisfied our condition. Anything that was not less than 35, we jettisoned. It's gone now, at least in that modified version of it. So the filter call keeps the stuff that satisfies the condition. It gets rid of the stuff that doesn't. And specifically, it keeps the rows. We can see that if we output to text, we still have the ID column, the A column, the B column, and all of those still have their original values. And in a bunch of these, the very first row, the B column has 45.0. 45 is greater than 35. So why is that still there?
Because it's in the B column.
Because it's in the B column. We only filtered based on the C column. So that is what filter does. But there is still a question of what is up with the text that we put in here, with the language that's used for this filter call. This is pretty different than anything we've really done with Quorum in the past. If for folks that have been here in previous years, this doesn't look like anything that we've really ever done as part of the games or anything. We have frame : filter, and then we just pass it a string. We pass it a text value, right? And this text value contains C less than 35. So first question, this C value, this isn't a variable. This isn't something that we stored somewhere. It's literally just part of the text. How does the frame know what that means?
Magic.
Yeah. Well, it's like when we set a selected factor, you can put in the name.
Right. So when you use selected factor, we gave it the name of a column, and it just sort of magically figured it out. And in this case, we're doing a little bit of magic again, where the frame, because it's loaded this data, it knows that the data contains a column named C. The compiler is smart enough to figure out, or the frame is smart enough to figure out, that C is talking about a column named C in your data set. And from there, it's also smart enough to even do some extra logic where it says, if you give me some basic operators like a less than, a greater than, stuff like that, and you give me some values, it is smart enough to do some basic operations on it. It's not a whole programming language. So if we tried, I'm sure we could figure out a way to break that text that we're sending pretty easily. It's constrained, but that's basically what we're doing is you can take a little snippet of the same kind of code you would use in an if statement, basically, real constrained. And you can apply it real basic stuff onto the columns in your data frame to filter out some of the rows. Any question about how the filter works or about anything that we've done in terms of filtering the rows?
Can you only filter by less than, greater than?
So if Stefik is here, I think that he would know the full gamut of what's available. But I think that
I'm here. I can answer that.
Yeah, you can. So what are the full range of things that are allowed in the filter?
So short answer is I don't remember. I programmed it, but that's not really. So I should have it memorized, but it's a subset of the language. So basically, most of the major operations are supported, like less than, greater than, equal than, stuff like that. But I recall we don't allow anything that's super advanced. So you can't like call functions in there and do stuff like that. And the reason for that is not because I think that we're taking a position like that's good or bad, but it's that we ran one randomized controlled trial as a study, because I'm obsessed with evidence, on how we can embed these little things. And we basically came to the conclusion that you can embed them, which is what R and Python and other programming languages do, but they have to be kept really simple, because if they aren't, what you end up with is some very, very complex filtering code. So we're still kind of hammering out exactly how expressive we want to allow in the system. That's a long-winded answer for basically saying it's all the normal operations like and or, less than or greater than, not equal, stuff like that. But you might run into an operation here and there that it doesn't do. And if you do, let me know if you really want it.
I actually don't know if we do have and or in here, do we?
Pretty sure.
Like, is this reasonable code, C less than 35 or C greater than 10?
Let's find out. Look at that.
Yeah, okay. So yes,
Yeah, and an or is there, equal, not equal.
ignore my skepticism then.
I do recall, and maybe this is dumb, and I shouldn't admit it publicly, but if I remember correctly, I think I actually forgot to include parentheses in there, which was a total accident. But so if you do parentheses, that it might choke. So you can always try that now to make sure. But I recall that's more like an oversight on my part that I'll fix later. But so it's pretty expressive, but not.
That's choke.
Did it run?
Yeah, it produces no output at all if you filter it with
That
in there.
sounds like something I would do.
So, limits
yeah,
to it,
so
yes.
There's limits, but it covers most of the major like operations basically. So sorry, that's the answer I got.
So yeah, long-winded, but yeah, greater than, less than, and or the basic operations like that, but don't try and run the whole programming language in there. Does that answer your question?
Yes, yes, very much so.
All right, so that's how we filter on the rows. We can also filter along on the columns. This has a bit of a different purpose than filtering on the rows. What are some examples of when we might want to remove some of the columns from our data set?
Oh gosh, we do that all the time, hiding columns and stuff. That's a no-brainer.
Yeah, you got some garbage in there you don't care about. Just get it out of here. It's in the way, right?
Like the wine description that's like
Totally
10 pages long for each wine.
Yeah, we don't need this. We can get rid of it, and we're just going to pare our data down to what we actually care about. So let's get rid of some columns. So we're going to be using that data that we were talking about previously, that salary data, the spreadsheet that had missing values, that had some misnamed stuff. It also had just a bunch of junk in it that we just probably don't really care about for whatever we're looking at the particular moment in time. If we look at that, let's suppose that we want to get rid of a couple of particular things. There is a column called additional context on job title, other monetary comp, currency dash other, or additional context on income. These live at particular locations in our code. So before I use the remove column at code that's in this example here, I just want to take a moment and I want to output the frame without removing anything, just so we can see it again in the raw text, right? So right now, the only thing I'm doing in this data is I've got my use statement for the data frame. I have, once again, this use statement that you don't have to worry about for the remove undefined rows transform. I have the data frame. I load the frame with data/askmanager.csv. I've commented out my remove column at call, so we're not removing anything yet. We're not doing any filtering on this at the moment. I'm just outputting this frame to text. If I do that, I can see that our data currently has these columns: timestamp, how old are you, industry, job title, additional context on a job title, annual salary, other monetary comp, currency dash other. There's a lot in here. Even still, I've still got another dozen or so extra things in here. So it's a little bit of a hassle, but unlike the rows, we can generally assume that the number of columns is going to be something that is countable on fingers and toes and maybe a little bit of extra help from a friend. It's not so overwhelming that we can't go figure out where each of these lives. So let's start by, we want to get rid of the additional context on job title. I'm going to have to remove a column at a particular index to accomplish this. So the code's already here, and there's a comment that says what it is. So there's some cheating that's allowed here. And by cheating, I mean basic reading comprehension. It's fine. But I'm going to ask anyway, what column should I remove to get rid of additional context on job title?
You just count over.
Yep, we're just going to count over.
But
So
starting with 0 is
starting with 0, right? So timestamp is at 0. How old are you? 1. Industry, 2. Job title. Wait, did I count that right?
3.
0, 1, 2, 3.
Yeah, you did. It's 4.
It's 4. Wait a minute. Is this thing not right? Ah, it's wrong. Amazing. So the code that's already there is actually off by 1. So it's a good thing that we're double checking it then. So if we looked at the raw value, timestamp at 0, how old are you at 1, industry at 2, job title at 3, additional context on job title is at 4. So what we need to do is we need to remove the column at 4, right?
Yeah.
If I go ahead and I do that now, and I run it, I can now see that in here, timestamp, how old are you, industry, job title, and then jump straight to annual salary. The additional context on job title is gone now. Okay, so I'm going to go ahead. I'm going to show the raw text again. So this is, once again, I've taken my filter call back out. Our original text. I want to remove other monetary compensation, other monetary comp. So let's figure out where that one is.
Now, do you have to start back like with the original? So you would still count the one that we just removed at 4, or?
You are catching me before I've even sprung my little trick on you guys.
Sorry.
Yes. So you're totally right, though. That is something that we are doing. I have gone back to the original data, and I'm asking you to count for where we need to do it in this data again. But as we're about to see, because we removed one ahead of it, its position is actually going to shift by 1, right? If we wanted to remove just other monetary compensation, we could count it out in 0, 1, 2, 3, 4, 5. It's at 6. Okay, so we remove the column at index 6. And if that's the only filter call that I do, I run this now, we can see that the other monetary comp is gone. It's been removed. But now if I comment back in my previous filter, so now I have 2 remove calls. I have frame remove column at 4, and I have frame remove column at 6. And theoretically, what I'm attempting to do is I'm attempting to get rid of additional context on job title, and I'm trying to get rid of other monetary compensation. But if I run it, I'm going to find that other monetary comp is in fact still there. So you were just asking about this, but why is other monetary comp still there? If I just showed that if I do it on its own, it will get rid of it then.
Is it because they're 2 different calls? Can you put just one call and separate them by commas for 4,6?
Someone could correct me if I'm wrong. I don't think that you can remove multiple at one time with this function call, at least not comma separated. I think that there
might be a call for that. I'm trying to remember. I know that I wrote some for some of them, but I don't.
I think that there's a range remove. I'll just use the Quorum Studio thing I have open real quick to just double check. So, that's annoying. So if you wanted to, we could remove.
Oh, you remove selected column range. Oh, remove selected columns text headers. You can do comma separated headers that way with the names.
Okay.
But the downside is if you have a data set with non-unique names, that won't work. Like if they're all named A, it's not going to know which A you want removed, right? So now, granted, I wouldn't recommend naming all of your columns A, but that's neither here nor there.
Does remove selected columns only affect the selected columns, or does it affect the rest of the thing?
Oh, shoot. You know what? You're right. That would do that. I wonder if this is an oversight. Hannah, can you mark down that we should take a look and see if there's a convenience function we forgot here?
Yeah, I'll add it to the list to just have it on the actual frame.
Yeah, great. Thank you.
So I think that the general answer to this is it might be possible to remove more than one at once if you do it in a very specific way, but there's not a convenient way to do it for what we're doing right this second. But even outside of that, although that is entirely reasonable that you'd like to ask, can I just not do this in like 5 lines of code? Can't I just do this at once? Can't you just do this for me? Outside of the very obvious and very reasonable question of, can we not just do this all at once? Beyond that, why is it that if I remove the column located at index 6, that gets rid of the other monetary compensation? If I do it all on its own, but now that I'm removing the column at 4 just before that, now it doesn't work anymore. Now I'm removing something else.
Because now it's at 5.
Because now it's at 5. Whenever you remove something, it's not just an empty spot that has nothing in it now, and it's just sort of living vacuously in a void. Whenever you get rid of something, a certain column, everything else shifts forward to fill that space that just got opened up, right?
So the order in which you put them in is very significant.
Yes. So if I do remove the columns at 4 and 5, that will correctly get rid of additional context on job title. That's gone now. And other monetary compensation, that one's gone now too. But if I wanted to do it in the other order, if I removed the column at 5 before I removed the column at 4, well, now I've broken it again, because now other monetary compensation is still in there, even though it's the same indexes I've removed. All I've changed is the order of them, right? So just something to pay attention for. If you're counting out the headers, you're going index by index, you have to either, if you're going to do them in the order they appear, you have to make sure that you're accounting for how they're going to shift forward for each thing that you remove. Or you could do them in reverse order with their original things, because removing something from the end isn't going to change the index that the stuff at the beginning's at. But either way, you just have to be paying attention for where you're removing the stuff from if you want to make sure you're removing the right stuff. There's a little bit of magic going on with index values and whatnot here. Does that make sense to everybody? Does everyone have, or does anyone have any questions about that?
It makes sense. I'm just trying to think of like how we're going to explain that to a student who's not just going to try and wipe out their whole code.
I think we would need to use some physical things.
Yeah, you're going to
right?
have something physical besides reading the gazillion comma
Yeah,
separated files here.
Yeah.
I'm thinking of using like the 5 and 10 frames, and like you okay, we just removed it, now count for, okay, now we removed, yeah, like physically do that.
What's a 5 and 10 frame? Sorry if that's a dumb question. I've never
No, it's just like to learn place value. It's just a
Oh.
tactile, yeah.
There's a couple different things like that where it's like, yeah, place value.
You could probably do it with an abacus. That might be a fun way to do it.
The good news about this removal thing too is it sounds kind of esoteric, but this is actually true across any programming language. So learning this particular skill of removal, it's true for arrays, lists, hash tables. It's true in Python, Quorum, C++, Java, because this is just kind of how memory management works. Like when you remove something, you basically take anything past it, you chunk it forward. So it's sort of a standard thing that you learn about in computer science because it's true universally. Like it's almost always the case with certain kinds of data structures that this is how it works. So the good news is, if you are teaching students this kind of like weird skill, it's quite applicable across many different aspects of computer science.
Cool.
Yeah, I just think the how to get the concept needs to be more hands-on at first.
That makes sense.
Than looking at this raw data and counting columns. Like
this is a little bit of a extrapolation
dots.
we've made out of here too. So
yeah,
explaining to start with 0 instead of 1.
Yeah.
Unless you're taking CSP and then you have to start with 1 on the test.
Yeah, it's so funny that they did that too. The amount of evidence that the College Board has that that's a good decision is in fact 0. They have no evidence that that's a good decision.
The only reasoning I've gotten is because Scratch does it that way.
Oh, I know. I've talked to the folks out there. They're really nice people. Don't get me wrong. It's just that like sometimes computer scientists over the last 50 years have made many, many non-evidence-based decisions, and they kind of like, so you know, when they take CSP, oh, it's 1 index now because reasons, you know. So yeah, it's a thing far beyond just CSP too. So complicated thing. Anyway.
Yeah, I can see why this would be difficult to convey. Definitely, if the main point of this was to teach indices, this is definitely not the lesson that you'd want to, or the file that you'd want to use, because boy, howdy, that's a lot. But either way, for right now, we have gone through how you get rid of rows. We've talked about how you get rid of columns. But we haven't touched on that original problem that we were talking about. What happens if I have a data set and it's not that the data set has junk that I don't want, or maybe it does, but that's not its only problem, right? Maybe there are columns and there are rows that have things I actually care about, but they are messed up somehow. The value is missing. The value is supposed to be the same as another one, but it's been put in wrong. There's a typo. You know, the person who put it in thought they should use an abbreviation. We haven't talked about how do we adjust our charts, or not, sorry, not our charts, our data frames to be clean and tidy and sort of universally usable by the stuff that we actually care about in Quorum. For that, we need to start talking about replacing values. And one of the obvious ones is the undefined value. This one's going to come up a lot. This is the case where someone said, what is my additional compensation? And instead of putting 0, they put nothing in there. And we don't know how to add the raw concept of undefined as part of our summation, right? We could just straight up get rid of the undefined values, but let's start by talking how we could replace them with something else instead. So if we want to replace the values in our data frame that are undefined, there's nothing in there, and we want there to be something there, we have a couple of different options. We can either use just the replace undefined action, and we have the replace undefined selected columns action. The difference being that the first one just replaces all of the undefined values with something. The replace undefined selected columns one replaces all of the empty elements, all the undefined somethings, but only in specific columns that we have selected ahead of time. Why not just always do it to all of the undefined things? They're all undefined. Clearly, we don't want them to be undefined. Why not just replace them all with something? Okay, I'm seeing some looks of confusion. I don't think I've explained what this is doing well. Suppose that I have in my data frame, right? I have the spreadsheet up for the Ask a Manager salary survey. This is the same messed up one that we've been using before. It's the same one that we just removed some of the columns from. If I use the replace undefined values action, I just do all of the undefined values, that will replace all of the things that are empty on the spreadsheet with whatever one thing I say. So I could say replace all of these empty spots with 0, right? That's an option that I could do. Or I could use replace selected columns with something if they're undefined. So I could select just how much additional monetary compensation do you get. I could replace just this one column, replace the undefined values in it with 0 or something else, right? So the question is, why would I bother to select one or a few columns at a time and replace just some of the undefined values instead of just replacing all of the undefined values with 0?
Well, because undefined over there on gender as 0 doesn't make a whole lot of sense.
Right. That's exactly it. If I replace everything with 0, then I now have to question how the gender of 0 impacts whatever I'm doing with this. If you're in the US, what state do you live in? I live in the state of 0. Okay. If your income needs additional context, please provide it here. 0. I will provide you 0 context. Am I supposed to sum that up? What am I supposed to do with it? It doesn't necessarily make sense to replace everything in your data that is undefined with one singular value that's going to be the magic undefined for everything, because it's going to be context dependent. So there might be some data sets where it makes sense. All of your values are numbers. You just want all of them to be 0. So sometimes it might be useful, but a lot of the times you want to be a little bit more precise, a little bit more targeted about how you are replacing stuff. So as far as the undefined values go, I've been talking a lot about just empty stuff. There is nothing in here. There is another case, though, where we might consider something to be undefined or an invalid value, though. Suppose that I have in my data the field where I say, please tell me how much you make in a year. And then the user very helpfully provides bagel. They make bagel number of dollars in a year. That is nonsense. It can't be added to our other numbers. It's not a dollar amount. It's not an integer or a number. That is going to be an invalid value just as much as that empty value was. So that's another case where we might want to replace something in our stuff. In the case of these replace undefined actions, bagel is not valid, but it's not the same as being undefined, right? So we will need to be a little bit thoughtful about how we are replacing some of these. And if I'm saying something wrong about the filtering, please correct me, Andy. But I believe that remove undefined is not going to remove bagel from your dollar count column. So let's consider this case of what we want to do with the data set we were just talking about. We have our askmanager.csv, and we want to replace some of those numerical values that were empty with zeros. So we're going to start by taking our askmanager.csv. We're going to get one column. We're going to add selected column 6, which I believe selected column 6 is going to be the additional monetary compensation. Actually, don't know if that's true. Which one is this?
It is true if you haven't taken anything else out.
Well, you know what? When in doubt, we're going to just output this to text anyway, so we'll see what that is. So if I run this, the code currently has the use statement for data frame. We make a data frame. We're going to load it up with that same data we've been using. Then we frame : add selected column 6. This is the same sort of selected columns that we were using for the charts. The selection isn't different between how we were doing stuff for the charts and how we were doing stuff for the data, which is part of why you might end up using those set selected columns or set selected things in general, because you might end up doing some stuff where you're selecting, using that to do some filtering, and then after the fact, you're then going to later go and use the exact same data frame to go do some charts later, and you might need to replace that selection. Once we've selected our column, we've selected column 6, that's 0, 1, 2, 3, 4, 5, and 6. Yep, other monetary compensation. And we replaced all of the undefined values in there with zeros. So now if we were to look, which this is not formatted in a way that makes it easy to tell at all, but there are zeros that have been inserted here anywhere where there was an empty value before on that data frame for that one particular column. Any questions about how replace undefined from selected columns works, or generally what we're doing when we're cleaning up the undefined values in our stuff? Okay. So the last thing we're going to talk about is, instead of replacing the values, we might just want to straight up get rid of them instead. When we're getting rid of these values, it's going to look similar to what we've done, at least in the concept of what we want to achieve, right? We have some columns, we have some rows, which contain values that are undefined. We don't like that because that's a problem for us. So we're going to do something with them. Now, what should we do if there is a row and there's an undefined value in it? We've seen one option. We could replace that value with something else. What else could we do instead of putting a different value in that cell?
Remove it?
We could remove it. What are we removing? Are we removing the cell? What would that mean?
Your
I guess
data shift, and then your data would be all skewed.
Yeah, you can't just like poke a pocket in your data without skewing everything. So if we're going to remove it, we have to remove enough that we're not going to skew everything, which means that we have to chunk out the entire row if we decided that's how we were going to do it. We could decide that when we're handling askmanager.csv or whatever it was called, when we're handling this data, we could say, I'm sorry, you put your country of residence is nothing, it's undefined. we just won't consider you as part of our model because your data is not formatted in a way that it means anything to us. We can't make any reasonable assumptions off of this. We can't even provide a default that would make sense. We're just going to straight up get rid of this row of data because it's not relevant, right? If we wanted to do that, we would use a funky little object, the same thing we've been seeing these use statements hanging around for. Remove undefined rows transform, all one word. That's quite the name. What the heck is that thing? So what the remove undefined rows transform is it's an object. It's a thing that we can get a use statement for. We can make a variable for it. And it is going to let us do some stuff with the data frames. The data frames know how to take these crazy transform objects and do stuff with them. For a lot of these things, it's beyond what's necessary to just do a basic cleanup of this data. But what we can do here is, I'm going to move down to the code. We have here use libraries.compute.statistics.dataframe, the exact same thing we've been using everywhere. And now this use statement that we've been ignoring up until now, use libraries.compute.statistics.transforms.remove undefined rows transform. This use statement is going to make us, or is going to allow us to make a variable of the remove undefined rows transform type. It's a long name, it's really wordy, but it's just an object. It's a type of object, is a variable, or it's just a type of object that we can make and put in a variable, just like the data frames, just like the pie charts, the bar charts. It's just a thing that you can make a variable out of, right? In our code here, we make a data frame. We load that same askmanager.csv, the same file we've been using with all of its problems. And on the next line of code underneath, we make a remove undefined rows transform. So the literal line of code is remove undefined rows transform, all one word, space, some name. In this case, we call it transform. And then on the next line down, we say data frame clean equals frame : transform, left paren, and the name of our transform. So transform, right paren. From context, I think we can guess as to what clean is going to be. But what exactly is happening in this line of code? Data frame clean equals frame : transform, left paren, transform, right paren.
You're making a new data. Well,
So you're on the right track, yeah.
you're making, you're cleaning up your data. You're removing the undefined. I'm not.
Yeah. So you're on the right track. We have our data frame. It has rows in it which contain undefined values, and we don't want them. We are making this crazy object, remove undefined rows transform, and it does something. We don't need to know all the nitty-gritty of what this transform is, but what's important is that the data frame has an action that it can use called transform, and it can take this remove undefined rows transform. It can also take other things that we're not going to talk about right now, but there are other types of transform objects that could do other stuff. You could make one to manipulate the values somehow by, like, multiplying them all by 2. I don't think that's something that exists in the standard library, but you could make one if you really wanted to. There's a series of other transforms that could exist, and basically, whenever you see an object that ends with that transform in this in the context of the data science stuff, basically it just says this object knows some magic to manipulate whatever data frame is willing to accept it. So when we say frame : transform, if you pass it a transform object of the remove undefined rows transform type or of different types that we're not looking at right now, somehow the frame will change. It's going to transform it somehow. And in this particular case, the remove undefined rows transform says, I'm going to get rid of all of the rows that have undefined values in them. And when it's done, that frame gets given back to us, and we can store it here in this new variable. I believe that the remove undefined rows transform makes a copy and that's what's getting returned, but I actually don't know if that's true. This value that data frame clean is, I think, is a brand new data frame, and I think you still have the original as well. Well, actually, I could test that real quick. And we see if we try this code where we output the clean value, remove undefined rows transform was maybe not the best thing to apply in this particular case, because that particular data set had hundreds and hundreds of rows. After applying that transformation, we have 3 rows. There were only 3 rows in this entire thing that didn't have any undefined values in them at all. So maybe this wasn't the ideal way to clean up this particular data. I don't think we're going to be able to get much information out of this on these 3 rows. But what's important is if you were in a situation where your data set cannot reasonably be interpreted because some undefined value somewhere, there's no reasonable replacement to put in there that will preserve the integrity of your information. And you just need to say, if you have undefined stuff, I just can't trust that this value is any good. You could remove it from there. And you could also combine this with our other stuff. We saw before that we can remove columns, and we said, why would you want to remove columns? Well, there's just junk that we don't need in there and we don't want it. But another way that we could apply that in is we have this column in our data set that says, if other, please indicate. This thing is just empty as all get out. A lot of these are going to be empty for this if other, please indicate column. We could say, remove that column because it's going to be irrelevant to our stuff anyway, and it's got a bunch of undefined values. And then after we've gotten rid of a column, now we're going to go remove our undefined rows, now that we've removed one of our major problem things that we didn't even care about anyways. So combining these together is going to get you closer to getting the data in the format that you want or need it in. So it's just about noon. Are there any questions in terms of the remove undefined rows transform and what it's doing, in the general sense of removing stuff or cleaning up our data in general? Any questions on anything we've talked about here?
I was going to add one little minor thing for that remove undefined row transform. There actually is a function in data frame that you can call that I put in Slack, which is just remove undefined rows. I'm guessing the tutorial was written before we added that function. So you don't have to do it through this transform way, but that is what the tutorials show, and that is valid as well. So not that important.
All right, any questions? Have I lost everyone to such a degree that no questions can be asked because we don't even know what's going on to ask questions about? I see one head shake and one head nod. So in that vein, yeah, the much easier way to do this would be to use what Stepik posted in the Slack channel, which is just frame : remove undefined rows, and then you just don't worry about this undefined transform, whatever this thing is. Just let the frame handle it for you, because this way of doing it is obviously a little inconvenient. So there was an easier way added later to do this.
Yeah. Okay, so I think that, thank you, William. That some of the filtering stuff, it's really powerful because you get, it's really easy when you get a spreadsheet to just go kind of tweak it by hand. But one of the things about data science is that we often automate how we do this stuff, because then the next person that runs our analysis gets the same answer. So, right, they don't have to pretend what our steps were. So learning how to do this in an automated fashion is really, really important skill for students, because once they can automate their, not just building the chart, but cleaning their data and adjusting their data and tweaking their data and all this kind of stuff is really, really important. So thank you, William, for the intro to that.